So now that we're well versed in properties of logarithms, we're going to learn an important application of logs, which are log equations. So the reason you need to be strong in properties of logs is that you can solve their equations, because that's what it boils down to. Solving a log equation boils down to how well can you apply the properties of logs. So the properties of logs here that we can recognize is an addition. Before we do that, let's just discuss two possible outcomes for solving log equations. In the end, eventually, you'll either cross out the logs or you'll do left, right, center to get rid of the logs. Because eventually we'll have to get rid of those logs. How do you get rid of them? The way you do that, to both sides of the equal signs have a log. If both sides of the equal sign have a log, eventually you'll cross them out. If you have log equals log. In this case, not every term has a log. So we'll have log equals number. In that case, left, right, center to get rid of the log. So the point is to get either log equals log or log equals number. The way you do that is by combining logs using properties. The property applied here is the multiplication property. We're adding logs, log plus log. The word log means exponent, so we're adding exponents. You add exponents when you're multiplying. So we're going to multiply the of portion of the logs here to combine the left side of the equal sign. So we have log base 3 of, and x plus 4 times x minus 2 is x squared plus 2x minus 8. And that still equals 3. So now, halfway there, log equals number. So now I can convert this to exponential form, left, right, center. So x squared plus 2x minus 8 equals 3 to the third power. Well, I know that 3 to the third power is 27. And now this is a second degree equation. So let's get this into standard form. After getting this into the standard form, I have to see, is this factorable? If it's not factorable, I may have to complete the square, or I may have to use the quadratic formula. So after getting this into standard form, I end up with x squared plus 2x minus 35 equals 0. Thank goodness this is factorable. So we have x plus 7 times x minus 5 equals 0. So we have solutions of x equals -7 and x equals 5. So now when I'm done, I have to look to see which of these are acceptable. The way to do that is by looking at the of portion of the logs. The of portion of the logs can't be 0 or negative. So this log, x, has to be greater than -4. Because -4 will give me a 0, unacceptable. -5 will give me a negative, unacceptable. Logs do not exist for negative numbers. And in this case, I have to have x is greater than 2. So I'm looking for the intersection of both of these domains. The domain of this function, log base 3 of x plus 4, is x is greater than -4. The domain of this log is x is greater than 2. So I have to look to see which, this has to satisfy both of these. So -7 is definitely out. -7 is not greater than -4. 5, yeah, that's greater than -4. It's greater than 2. Therefore, this is my only solution. It is possible that you reject both. It's possible that you reject neither. In this case, I just had to reject one because it didn't satisfy either of these domains for the logs. Again, the inside of the log can't be 0 or negative. Let's do another example. So now I have 2 log base 2 of x equals log base 2 of 2 plus log base 2 of x again. So now every term has a log here. So eventually, I'll cross out the logs. So I'll get log equals log and then cross out the logs. Before applying properties, can't have any coefficients of logs. So make that an exponent right away. So we have log base 2 of x squared equals log base 2 of 2. And I'm applying properties here. I'm adding logs. That means I'm adding exponents. I add exponents when I'm multiplying, so that's what I'm going to do. I'm going to multiply 2 and x, 2x. So now if you look, I have log base 2 of x squared, log base 2 of 2x. So I can, for all intents and purposes, cross out the logs. Really what I'm doing is putting the inverse of log base 2 on both sides. So I'm putting a base of 2 on both sides, really, because log base 2 is, the inverse of log base 2 is 2 to the x power. So what I'm really doing here is putting base 2 on both sides the inverse of log base 2. So we have x squared equals 2x. This is a second degree equation. Let's get it into standard form. X squared minus 2x equals 0. Factor. I get x equals 0 and x equals 2. Let's go back and check the of portion of the logs. This domain, x has to be greater than 0. This is a number. In this domain, x has to be greater than 0. So, I cannot accept this. I can only accept that. There's another way you could have thought about this, and that's the beauty of logs. There's so many different properties you could apply that there are probably 3 different ways I could solve this equation. Let's try it another way without erasing the original question. Let's see if I can do that carefully. That's good enough, all right. So now, what we have here is 2 log base 2 of x equals log base 2 of 2 plus log base 2 of x. If you look carefully enough, these are like terms here. Let's subtract them from both sides. Let's subtract log base 2 of x from both sides. Minus log base 2 of x, put it on both sides of the equal sign, minus log base 2 of x. Well, 2 log base 2 of x's minus 1 log base 2 of x is just 1 log base 2 of x, and that equals log base 2 of 2. So I have log equals log. Cross them out. X equals 2. That was a lot easier. Let's think about this one more way. This way is a little difficult, but hey, it's possible. Let's get rid of this. And let's say that we had said, well, I know log base 2 of 2 is saying 2 to what power is 2? Well, 2 to the first power is 2, so this is 1. Let's bring the 2 up and say log base 2 of x squared equals 1 plus log base 2 of x. So let's get the log to the other side. Log base 2 of x squared minus log base 2 of x equals 1. Now I have a log equation where there aren't logs on both sides. So I'll combine these logs and do left, right, center to get it into exponential form. So we're subtracting logs. That means we're subtracting exponents. That means we're dividing. We're dividing the of portion of the logs. So I have log base 2 x squared over x equals 1. Just combine these 2 logs with the division. Now I can do left, right, center. 2 to the first power equals x squared over x. X squared over x equals 2. And now I can cross multiply. Let's bring this up here so we have some more room. Let's cross multiply. X squared times 1 is x squared. 2 times x is 2x. And now we're back to the same equation which we had before. Let's subtract 2x from both sides. Let's factor out an x. And let's set both factors equal to 0. Okay, let's go back to our original. X has to be greater than 0. X has to be greater than 0, which is why we're going to reject this solution and only accept x equals 2. Okay, next example. This question was on the Regents exam, I think last year or even the year before. So it's a very recent question. So I think it was a 6-point question, believe it or not, which that's a lot of points on the Regents exam. That's the difference between passing and failing. So log equations, they're on it every year. So the first thing I'm going to do is say, not every term has a log. This side of the equal sign doesn't have a log. So eventually I'll have to do left, right, center. Eventually. But before I do that, I have to combine these logs. How am I going to combine them? Because I'm subtracting. What am I subtracting? I'm subtracting logs, which means I'm subtracting exponents. When do I subtract exponents? When I divide. That's what I'm going to do to the of portion of logs. So I'm going to divide them. So let's make it 1 log. Log base 4 of x squared plus 3x over x plus 5. And that equals 1. Now we can put it into exponential form. Left, right, center. X squared plus 3x x over x plus 5 equals 4. So now I can cross multiply. I'm going to move this over. I'm going to need a little more room here. So I'm going to cross multiply. This is over 1. X squared plus 3x times 1 is x squared plus 3x. And 4 times x plus 5 is 4x plus 20. So now we have a second degree equation. Let's get it into standard form. When we get it into standard form, we're subtracting 4x from both sides, and we're subtracting 20 from both sides. So now this is a factorable second degree equation. The factors are x minus 5 and x plus 4 equals 0. Let's set both factors equal to 0, x equals 5 and x equals negative 4. So now let's go back to the original equation. When is that equal to 0? We can't have x equals 0, so x has to be greater than that. Also, negative 3 makes the inside 0, so x has to be greater than negative 3. Okay, and in this case, x has to be greater than negative 5. So, having x greater than 0 is really the dominating term here. Get rid of that. So there's our only solution.